how long can you do without social networks, instant messengers, and the internet? Imagine that you have to fly to Mars and spend about 8 months in space. The long isolation of astronauts is very worrying for psychologists and is one of the big obstacles in front of our journey to the Red Planet. But what if there was internet service everywhere in the Milky Way? That changes things, doesn't it? Before we continue, I want to tell you about the sponsor of today's video, NordVPN. As I travel a lot, I often use Wi-Fi at hotels, cafes, and so on. But I don't want my credit card number stolen, as well as loads of other personal data. So I've started to use NordVPN recently on my phone and laptop to protect my online activity. And I must say, I'm really impressed. When you sign up for NordVPN, you'll take control of your internet experience. Another great thing about it is that it's super fast. This is because they've got thousands of servers in dozens of countries. And of course, it gives you absolute freedom. It even works in China. So I advise you to try NordVPN and protect your online security. Go to nordvpn.com/riddle or use the code RIDDLE for a special holiday deal. Get a 3-year plan with 81% off, plus 2 amazing gifts, 4 extra months, and the NordPass Password Manager app. And now, let's continue. Only in outer space, there are many challenges to creating an interplanetary or even interstellar network. Huge distances, even to our nearby moon, require a long time for communication signals to travel, which creates delays. Cosmic radiation, in turn, will present a powerful obstacle that will regularly interrupt the signal. In addition to this, planets constantly rotate around their axis and around the sun, and because of this, they'll often pass out of the signal range. Take, for example, Mars. The distance from the red planet to the Earth at different times is from between 34.65 to 249 million miles. That's about 55.76 to 401 million kilometers. That is, the time it will take for the signal to reach Mars will take anywhere from between 3 to 21 minutes. So, any urgent message can't be transmitted immediately. We'd have to wait quite a long time. In addition, even the most advanced modern space technology that provides communication with Mars operates at the level of internet connection speeds of the 1990s, only 256 kilobaud per second. And this is the closest planet to us. What could we say about the outskirts of the solar system or the far corners of the galaxy? An attempt to solve a similar problem back in 1945 was made by British science fiction author Arthur C. Clarke in his article, Extraterrestrial Relays. He described the possibility of placing orbiting satellites spread across a distance of 3.7 billion miles, or 6 billion kilometers, from Mercury to Pluto, when it was still considered a planet. In 1959, George Mueller and John Tabor continued Clarke's ideas and created the first satellite project that could provide communications via radio signals outside Earth orbit. True, this method has several disadvantages. We turn again to Mars. Every 780 days, the sun is between the Earth and Mars, so all communication signals will be blocked during these periods. With other planets, the same situation arises. However, there's already a proposed solution to this problem. Most satellites are usually placed in the so-called Keplerian orbits, that is, such trajectories that pass around the planet while moving with it. But as spacecraft are put into non-Keplerian orbits, then the satellites will be located a little away from the planet and will always be available for signals from the Earth. In this case, each device could be individual components of a single system with which it would be possible to transmit signals throughout the solar system. Scientists Stephen Davidovich and Joel Whittington calculated how many satellites will be needed for this. According to their assumptions, it should be enough to place 3 spacecraft in orbits perpendicular to each other around the sun, and the same number of satellites around each planet of the solar system that we would need to establish communication with. But this option is more suitable for radio communications and not for the internet like we enjoy it on Earth. The fact is that when transmitting information between terrestrial computers, that information is split into separate small pieces of data and after receipt is pieced back together again. At large cosmic distances and with interference, it's possible that a significant number of pieces of data will be lost, creating poor communication. Therefore, the interplanetary internet will require a different architecture with special ways of exchanging data. Fortunately, there is such a method. We're talking about DTN, Disruption-Tolerant Networking, a network that is very resistant to violations. This type of connection does not require a constant connection between communication points. If you break the data into separate packets, you can wait for a free window to transfer them and successfully send them. In 2008, this technology was used to transmit data from the epoxy, which was located at a distance of about 20 million miles or 32.2 million kilometers from the Earth. In addition, for successful data transmissions in space, it's necessary to replace radio waves with laser radiation. The American LADEE probe, which went to the moon in 2013, has already used a laser system for two-way information exchange between the moon and the Earth. A special LLCD system was installed on board the craft and maintained communication with two ground stations. Data was transmitted from the moon to the Earth at a speed of 622 megabits per second, and from the Earth to the moon at 20 megabits per second. In the future, the laser system should enable the transmission of information 10 to 100 times faster than radio waves. Even if an interplanetary internet is possible in the foreseeable future, interstellar communication will not be so simple. The nearest star to us is Proxima Centauri, about 40 trillion kilometers or 24.9 trillion miles from here. Light can travel such a distance in only 4.24 years. To provide communications on a similar scale, you need a huge interstellar cruiser. For example, Icarus, existing so far only as a theoretical project. According to the idea, this cruiser should jettison empty fuel compartments into which radio or laser communication equipment will be placed. Thus, Icarus should leave behind itself a chain of satellites that will transmit signals to each other throughout the entire journey. But given the gigantic distance, a large number of these devices will be needed. True, this does not guarantee a sufficiently powerful signal. It would be equivalent to just a few photons. Even your smartphone emits a more powerful signal, approximately 1,024 photons every second. To strengthen the space network, American physicist Saikat Guha proposes to make thousands of copies of each signal and then combine them into one message. Thus, even if part of the information is lost, having numerous copies will allow it to be restored. But then again, in the case of successful communication, to reach Proxima Centauri, the transfer of information can still take years. Therefore, you need something that can move faster than the speed of light. In theory, several options are possible. First, there are several virtual elementary particles that are born through interaction of other particles and are capable of reaching superluminal or faster than light speeds. Secondly, manifestations of quantum entanglement can also occur faster than light. However, transmitting information using both methods is completely impossible. However, James Hill and Barry Cox, while conducting an experiment in 2011, discovered that there's a more feasible method of creating an internet at superluminal speeds. It seemed that an elementary particle called a neutrino was capable of transmitting information and at the same time moving faster than light. But it turned out later the data was obtained as a result of a malfunction of the Opera detector installed in the Italian underground laboratory Gran Sasso in the Alps. It captures a neutrino flux coming from a particle accelerator through rock 453.6 miles or 730 kilometers thick. The malfunction seems to indicate that the neutrino can't outrun the speed of light after all. However, according to Duncan Forgan from the University of St. Andrews in the UK, in order to build a galactic network, it's enough to place an orbital station on each planet in the Milky Way, so long as we also use laser systems that will shoot down the sun's rays, which interfere with communication. According to Forgan's calculations, this could take about 300,000 years, and also relies on the existence of 500 technologically advanced civilizations, apart from ours, being discovered in the galaxy. So far, not one of them has been discovered, so the best way is to create developed civilizations throughout the Milky Way. In the meantime, there's every reason to believe that in the near future, the internet will be available, at least everywhere in our solar system. So if you plan to participate in the colonization of Mars, you won't have to part with your favorite YouTube subscriptions for a long time, and you'll always be able to leave a comment under our video. In your opinion, how much can an internet connection improve the chances of a mission to conquer the Red Planet? And if you manage to be one of the first colonizers on Mars, what would be your first search query on the internet? If you liked the video, give it a thumbs up. Don't forget to subscribe to the channel if you haven't already done so. And click on the bell to receive notifications of new and interesting videos that are waiting for you ahead.